After his adventures in the mysterious cave, John C. continued his journey westward. He walked for a long time and came to a small town. In the evening, resting in the saloon, he had the opportunity to talk to different people, and at one table a small company of local cowboys gathered. The conversation turned to horses, and these guys started boasting to John C. about how many horses each of them had. Here is their conversation. Robert says,
"My friend Thomas only has 2 horses, and William has 1 more horse than Thomas. William and I have 8 more horses than Thomas. I have more horses than Thomas and William combined."
Here are Thomas's words.
Actually, William doesn't have a single horse. Robert is lying when he says there are only 2 in my corral. Our herds are different. William and Robert together have 13 horses.
And here is what William said.
Thomas is the richest and luckiest of us all. I have 3 more horses than Robert. Thomas is lying when he says I have nothing. The 2 of them have an equal number of horses.
John C. listened to them and realized that the real cowboys love to boast and tell tall tales. The thing is, each of John C.'s interlocutors told the truth only twice out of 4 times. Can you help our traveler figure out how many horses each of his 3 new acquaintances has? Let's repeat their words again. Each made 4 statements. Only 2 of them correspond to reality. So here are Robert's theses. Thomas has 2 horses. William has 1 more. He and William have 8 more than Tom. He has more than Tom and William combined. Tom. William has nothing. Robert's words that he has 2 horses are a lie. He and Robert have different numbers. William and Robert have a total of 13 horses. William. Thomas has the most horses. He has 3 more than Robert. Tom's words that he has nothing are a lie. He and Tom have the same number. Remember, only 2 out of 4 statements from each speaker are true. The other 2 are false. You can pause to have time and try to find the solution yourself. Solution. First, let's briefly record all the statements made by the cowboys. We will take 3 variables representing the number of horses they own. Also, let's prepare such a brief table. The letters A, B, C, and D denote each of their 4 statements. Let's start looking for a solution with William's statements. Let's try to check if his first statement is true. Thomas is the richest and luckiest of us. If so, then Robert's second and fourth theses are false, because according to them, Thomas has fewer horses than William and Robert, respectively. Then, the first and third must be true, which is impossible because t equal to 2 is too small to satisfy the equality from the third thesis. It turns out that the number of false statements by Robert exceeded the norm. So, William's thesis A is incorrect. Now let's consider Tom's first statement. Suppose it is true, then William's second and third statements will be false, and with the false first one, this is too much. Therefore, Tom's first statement is false. And if so, then William's third thesis is true. Let's further assume that William's fourth statement is true. That is, that Robert and Tom have an equal number of horses. Let's see where this will lead us. The accepted assumption means that William's second statement must be false. According to the condition, each told the truth twice and lied twice. Obviously, then Tom's third statement is incorrect, as they are mutually exclusive, and the second and fourth are true. Now, based on this, let's analyze Robert's thesis. it turns out that his first statement is false. It is not difficult to understand that the fourth is also false. It is incompatible with the statement that Robert and Tom have an equal number of horses. Therefore, Robert's second and third statements must be true. But is it so? Let's consider the third statement. From it, considering the equality of the number of horses owned by Robert and Tom, it follows that William has 8 horses. And if we consider that the total number of horses owned by William and Robert is 13, then it turns out that both Robert and Tom have 5 horses each. Something here does not add up, right? We have come to a contradiction with the original data, because William should have only 1 horse more than Tom. Therefore, the initial assumption was incorrect, and William's fourth statement is false, as is the first one. Then the second and third turn out to be true. Let's immediately note that Tom's third thesis is true and move on to analyzing Robert's statements. Obviously, his last statement is false, as William has 3 more horses than he does. Let's now look at his first 2 statements. Suppose both are true. Then Tom has 2 horses, William 3, and Robert none. In this case, Tom's second and fourth thesis will be untrue, which is already too much, since he already has 1 proven false statement. Therefore, one of the first 2 statements by Robert is false. Both cannot be false, since there is already 1 false one. From this, it follows that Robert's third thesis is definitely true. Let's now assume that Tom's fourth statement is correct. Then simple arithmetic calculations will show that in this case Tom owns 5 horses, which means that Robert's first thesis is a lie. Accordingly, Tom's second statement is also true, which is impossible since then there will already be 3. Therefore, Tom's fourth statement is incorrect, and therefore the second statement is true. Based on this, it can be asserted that Robert's first statement is false, and since the fourth is also false, then consequently the second thesis as well as the third are true. Our table is filled. The truth and falsehood of all statements have been established. All that remains is to complete a system of 3 equations based on the truths obtained. Solving this extremely simple system, we get So, William has 10 horses, Thomas 9 and Robert 7. If you liked the problem and its solution, support the work of our channel, help us spread this video by sending the link to it to your friends.